Hello class, and welcome to our next video lesson. Today's lesson is on 5.6, and I've titled this Simplifying Radicals by Rationalizing the Denominator. And it sounds like a lot of scary words in this one. We've been doing radical simplifying the past few days, and now we're going to do another special time where what is called rationalize the denominator. And so if your parents ever ask you, hey there Billy, what did you learn in your video lesson today? You can come back with this really cool comment that you could just memorize, and it sounds really impressive. You can say, hey, well, Mom and Dad, I learned how to rationalize the denominator today when simplifying radicals. Doesn't that sound sweet? I mean, there's you think that you're smart, and you can be like, hey, yeah, that's what I do. That's who I am. So today's notes. Rationalizing the denominator. Remember what a rational number is. A rational number is a number that can be written as a fraction. So like 3/5. Obviously that can be written as a fraction. 7, that can be written as a fraction, 7 over 1. If we have 0.5, that can be written as a fraction. It is the same thing as 1/2. Irrational numbers are numbers that are decimals that go on forever and ever and ever with no repeating pattern, such as the square root of 3. This is irrational. If you put this into your calculator, it's like 1.7 dot 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 dot, and it just goes on forever and ever and ever with no specific pattern. So this is an irrational number. Now, one thing that we deal with radicals is that they're very difficult to deal with when they're in the denominator. So we do not like irrational numbers in the denominator. All we want is rational numbers in the denominator. All we want is rational numbers. So that's what we're going to be talking about in this lesson. So as you can see, we want to simplify this, and you might say, Mr. Berge, this is already simplified because the square root of 14 can't break down up into anything. It's 7 times 2, but I can't take the square root of either of these two numbers, so I've simplified it as far as I can go. That is true. However, like I said, mathematicians do not like to see square roots in the denominator. Excel math, you will never, ever, ever see a square root or a radical symbol in the denominator. So when this is the case, you have to do what is called rationalize the denominator. So you have to put a rational number down there. And here's how you do it. If I say the square root of 3 times the square root of 3, I multiply these two radicals together by multiplying the numbers underneath the radicals, and I get the square root of 9. And what is the square root of 9? Obviously, 3 is. So you can do this with any number. The square root of 4 times the square root of 4 is the square root of 16. And what's the square root of 16? 4. The square root of 5 times the square root of 5, that is the square root of 25. And what's the square root of 25? It is 5. So as you can see, when you multiply two radicals together with the same radicand, 3, 3, you get 3. Square root 4 times square root 4 is 4. Square root 5 times square root 5 is 5. You've changed an irrational number into a rational number. So we have successfully rationalized that number. So we are going to rationalize the denominator. In the same way that we got rational numbers with the square root of 3, the square root of 4, and the square root of 5, let's now get a rational number in the denominator. And I'm sure you guys can see where I'm going with this. How do you rationalize the denominator? Well, you simply multiply by whatever that radical is. The square root of 14, multiply it by the square root of 14. Now, as we know with fractions, 3/5, let's just say that, if we multiply the bottom by 2, now we get 10 in the bottom, yes? We also have to multiply the top by that same number, because we're actually just multiplying by 1 here. So 5 times 2 is 10, 3 times 2 is 6, 3/5 and 6/10 is the exact same number. We didn't change anything. They still equal the same amount. They just look a little bit different. In the same way, if I multiply the bottom by the square root of 14, I cannot change my fraction. It has to be the same. So I have to multiply the top also by the square root of 14. So now that I have this, let's do the denominator first, because we know the square root of 14 times the square root of 14 is 14. It's just the number underneath the radical, which is the radicand. And then I have to multiply these two together So a negative 4 times the square root of 14 is just a negative 4 square root 14. Now class, at this point, if you can simplify it all, you do so. And you only simplify the coefficients, or the number in front of the radical. So this right here can be simplified. It might be very tempting, class, to do this, cancel, cancel, but those do not cancel. The square root of 14 does not cancel with 14. So you can't cancel those. You can only reduce the coefficients. So you can reduce these two to make it a negative 2 square root 14 divided by 7. This is your answer for the very first problem. Negative 2 square root 14 divided by 7. Moving on to number 2. A negative 17 divided by the square root of 17. We have to rationalize the denominator, so we got to get rid of this by multiplying by the square root of 17. What you do to the bottom, you also have to do to the top. So the numerator also has to be multiplied by the square root of 17. So in the denominator now, the square root of 17 times the square root of 17 is 17. And then in the numerator, a negative square root of 17 times 17 is a negative 17 times square root 17. So now we can simply reduce. 17 divided by 17 is 1, so all we have is the negative square root of 17. This is our answer for number 2, negative square root 17. Moving on to number 3, we're now throwing in a variable in our denominator. What we have, class, is we have a square root in the numerator, and we also have a square root in the denominator. Do you remember how I said if we have like the square root of, let's say, 16 divided by the square root of 4? Remember how I said you can put all this underneath one big radical as long as the index is the same? So we can make it into the square root of 16/4. That is the same process that we're going to do with problem number 3 and problem number 4. Both of these have the same index of a 2. It's the square root. So I'm going to put this under one big radical, and it's going to be the square root of 15 in the numerator divided by 5q in the denominator. So now this helps us because we could simplify this. 15 and 5, that reduces to make the square root of 3, to make the square root of 3 over q. Because 15/5 reduces to 3, and then we still have this q in the denominator. So now, class, I can change it back into this mode, where if I have a fraction with that radical sign, I could change it up into two different radicals that have the same index, which is the square root of 3 divided by the square root of q. So now I've simplified it. So I basically moved this and simplified it to this, going through those two steps. Now, class, I'm still not rationalizing the denominator. I still have a square root in the denominator, and I cannot have that. So I have to multiply both top and bottom by whatever the bottom is, which is the square root of q. Multiply by the square root of q. So in the same way, the square root of 7 times the square root of 7 is 7. The square root of 10 times the square root of 10 is 10. The square root of q times the square root of q is q. So in the denominator, all we have is q. In the numerator, the square root of 3 times the square root of q is the square root of 3q. And now, class, we are all done. I want to let you know, to remind you, what we have here is we have an even index that resulted in an odd exponent. So what do we need to put down when we have an odd exponent with an even index? We need to put down the absolute value signs. So your answer for this one is the square root of 3q divided by q. And like I said earlier in the notes, it might be very, very tempting And so our answer is the square root of 3q divided by the absolute value of q. But class, I tell you what, I'm going to assume that you know this rule now with the absolute value. So for the rest of the notes, I'm not going to write it down anymore. I'm just going to assume that you understand that rule, and so from now on, you won't see me write that down anymore. So now, let's try number 4. Why don't you guys try number 4 on your own, and then pause the video, afterwards start it up again, and check your work with mine. So for number 4, hopefully you remembered, let's put everything under one big radical. 108 x to the 7th y divided by 3 x to the 5th y squared. So now we can reduce this fraction. 108 divided by 3, that is 36. So now you have the square root of 36 in the numerator. X to the 7th divided by x to the 5th makes an x squared on top. And then y divided by y squared is a y to the 1st in the denominator. So this fraction really got simplified to this. 36x squared over y, the square root of that. So now I'm going to make this into two different square roots again. The square root of 36x squared in the numerator and the square root of y in the denominator. Maybe as you were doing this by yourself, you understood that you could simplify this. The square root of 36 is 6. The square root of x squared is x. So you could bring a 6x out and you still have the square root of y in the denominator. Now that you have that, let's simplify this one step further by rationalizing the denominator. Multiply both top and bottom by square root y. So once we have this, square root y times square root y in the denominator is y. And then 6x times the square root of y is just 6x square root y. So this is our answer for number 4. 6x square root y over y. Problem number 5. A negative square root 3 divided by the square root of x. Pretty basic. You multiply both top and bottom by that denominator. Square root x times square root x. So a negative square root 3 times the square root of x, we're doing the numerator here, is a negative square root 3x. Square root x divided or times square root x is just x. That one pretty basic. Number 5, a negative square root 3 x divided by x. And number 6. This one is going to be another one that is a little bit more tricky, class. When we have a variable underneath the radical, if I want to rationalize this, what I could do is I could multiply both top and bottom by the square root of x to the 5th. And that would be a very appropriate way of doing this. You would get the right answer. However, it isn't the most efficient way. Let me show you what the most efficient way about doing this one would be. If I just multiply this one by the square root of x, if I do that to the bottom, I have to do that to the top. Now watch what happens. Excuse me. In the denominator here, I would have 7 square root. Now the square root of x to the 5th times the square root of x to the 1st is the square root of x to the 6th. And in the numerator, this portion, I would have a negative 10 square root 10x. So now, class, just by multiplying by the square root of x, did you rationalize your denominator? Hopefully you say yes, because can you reduce the square root of x to the 6th? What times what is x to the 6th? X cubed is. So you can bring out an x cubed. So our next step, our numerator is not going to change. It's still going to be a negative 10 square root 10x. Our denominator, we now know what the square root of x to the 6th is. It is x cubed. And there's our answer for number 6. a negative 10 square root 10 divided by 7x cubed. So that is problems 1 through 6 on our notes for today. Basically, the biggest thing that I wanted you to get from this lesson is that you can rationalize the denominator just by multiplying what the denominator is. Multiply by the square root of 5q, multiply by the square root of 17, multiply by the square root of 14, so on and so forth. Except for this last one, problem number 6, if you have the square root of x to the 15th in the denominator, all you have to do is multiply by the square root of x, because that makes the square root of x to the 16th, which you can take the square root of an even exponent there. So all you have to do is multiply these ones by the square root of x. I hope that makes sense. Be sure to let me know if that doesn't make sense, and we can go over more in class when we get there for tomorrow.